In this video about the field study of soils, we'll examine the horizons found within soil profiles. We will also demonstrate some of the field techniques for determining soil color, soil texture, and soil infiltration. Soil profiles are made up of distinctive soil layers, known as horizons. They are called horizons because they're generally found in a horizontal orientation. There are 5 types of horizons called master horizons. However, you might not find each of these horizon types in a soil profile. The 5 master horizons are identified by the letters O, A, E, B, and C. The O horizon is the organic horizon usually found at the top of the soil profile. The organic horizon is usually thin and is composed mostly of vegetative matter and debris. However, an O horizon in a wetland soil can be quite deep. The A horizon is the topmost mineral horizon. It's usually dark in color because of the organic matter that has leached into it from the O horizon above. The E horizon is a horizon where significant leaching called eluviation has occurred. Because of this leaching, the E horizon is usually light in color. The B horizon is the horizon of accumulation or illuviation. Clays and iron and aluminum oxides collect in this horizon. The C horizon is the parent material for all the horizons above it. It is the first horizon to develop, and it passes on characteristics to the horizons that develop later. The color of a soil is determined by many factors, including parent material and the amounts of iron oxides and organic matter. To determine the color of a soil, we most commonly use the Munsell color system. This system allows us to give a color a specific nomenclature, which is determined by its hue, value, and chroma. The hue refers to the quality of the color, which distinguishes it from another color. The value refers to the amount of lightness of a color, and the chroma refers to the strength or richness of a color. On a Munsell color chart, we find the hue at the top of the chart. The value is found to the left of the chart, and the chroma is found at the bottom. For this example here, the correct color nomenclature is 10YR 5/2. When determining soil color, we always want to use a moistened sample. We do this because no matter the field conditions, wet or dry, it is easier to moisten a sample than to dry one. Then with our moistened soil sample, we find the chip color that matches our soil the closest. It's important to do this in natural lighting. To better match the colors, the sample can be placed in front or behind the chart. With some practice, using the Munsell color system is an accurate way of describing color. The texture of soil is determined by the amounts of sand, silt, and clay. There are 12 classifications of soil texture, and if we know the percentages of sand, silt, and clay, we can use a soil textural triangle to determine the texture. While the fractions of sand, silt, and clay can be measured in the laboratory, we have to use the feel method in the field. A flow diagram like this one can be used to guide us to the right soil texture. To use the feel method, we first moisten 25 grams of soil. Then we follow the flow diagram. We first ask, does it remain in a ball when squeezed? Next, we try to form a ribbon by gently squeezing the soil between our thumb and forefinger. Can we form a ribbon longer than 2.5 centimeters? Does the soil feel gritty? This means the soil is a sandy loam. Soil infiltration is a measure of the soil's ability to allow water to infiltrate into and through the soil profile. The most common way to measure soil infiltration is by using a double ring infiltrometer. Once the rings are inserted into the ground, they are filled with water. Measurements are only taken from the inner ring. The outer ring ensures a more accurate reading from the inner ring. Water from the outer ring can move down and away, but the water from the inner ring can only move downward. This ensures we are only measuring the rate of water moving downward and not laterally. Here's a demonstration of how we use an infiltrometer in the field. We fill the rings with water. We take a measurement of the water level and start a timer. Here we've sped up the action. After 90 seconds, 8 centimeters of water has infiltrated. This gives us an infiltration rate of 5.33 centimeters per minute. To get a true measure of the infiltration rate, we have to take measurements for at least a 6-hour period. Once the data is collected, an infiltration curve can be created. This will give us a better idea of the soil's ability to infiltrate water.